Okay, then we have I think yesterday looks like 9th of words. I'll update on this. Oh, the 5th. Yeah, let's start. So we were on foundations and we understood like definition and I think the process ETL process, and I mentioned that some more process are there, and I think then this was the kind of a diagram we went through, that these could be the potential data sources, and then this is how the data looks when we store the data in as is format in this bucket bridge, and then keep on processing it up to the trusted data. So this is the initial data uh, which is not supposed to change. It is supposed to represent the exact format that we are getting from the source, and whatever changes we need on top of that we keep storing different data sets here. And finally, when we say the data is ready for consumption, for deriving insights to train the models on, so all that thing we put the data here, and the same data also can be loaded into data warehouses so that we can use SQL to analyze the data further. So that is something we covered. And then these were like catalog. We mentioned AWS Glue as the catalog service, and then lineage. This also will see in DBT how I mean, what the lineage is and like why we use that and how to get the lineage of some data. Then this is a compute part, and in compute mainly this is something we generally do. So it also represents a distributed system. So it like a single compute and another compute, and there is some connection between that. So it indicate that not only on a single machine, but whatever we design should be distributed. So just like Python, we have another framework called PySpark, and that is like a combination of Python plus Spark. So Spark is a framework which help us to distribute our jobs automatically. So whenever we write something, uh, the PySpark or the Spark framework automatically like distribute that into multiple clusters, and we can increase or decrease the clusters also. So and that is something which is being represented here. Then yeah, this is also we covered like AI modeling and then also visualization. Analytics team handles this part, then data science team handles this part, and then data sharing also we can do. We can share the data to the other companies or teams. So this is on the process part. Then let's see what else we have on the foundation. Yeah, this was the process. Then this chart, I think, supposed to be here. And yeah, so this is like the team placement where the data engineers placed. So this is like on the left side, or we call it the upstream. So upstream is the data sources that help us to like get the data from, and the downstream is like who is the consumers. So generally, data science team and analyst team are the consumers. So it's not like we directly communicate with the end user who is like customers. For example, in case of Spotify, so Spotify, for example, if I am listening Spotify music, that makes me as a customer or user. Now data engineer of Spotify do not communicate or interact with me directly, but they interact with the internally with a team of data science analysts in Spotify, and they further communicate with some of the team and marketing maybe, or whatever, I mean, the arrangement is. But the point is that data engineers, they communicate with them and they serve them. So these team send the requirement, and based on that, data engineers handle the part which is required to get the data from multiple sources, process them, transform them, so that they can continue their work from that onwards. And I think, yeah, skills. So skills basically is like, we know that SQL languages, in programming languages we are supposed to know at least one, and Python is a primary choice. We should know Python, and then Scala is another language that we can target, and then more languages also can come then. But I think Python covers a lot of ground. So Python, I would say, is the primary language, and if you master that, then you can also like include Scala also in your programming toolkit. But SQL is also like a separate, where it is also must know language that we need. And then cloud computing knowledge we need. So any one of the cloud computing would work. So currently there are a couple of services in the market, couple of companies, but one of them is AWS, another is Google Cloud also. So both are same, and Azure is not that popular, but that is also has a good market share. So I mean, these three are the primary, but maybe Alibaba Cloud is also there, and then I think some other services are also there, but AWS would be a good choice. So our curriculum is mainly specific to AWS, but I will also be telling the similar tools that we can use in Google Cloud also. So these two are like people use in organizations a lot. And then the basic knowledge of cloud computing, there where the services comes and why we use cloud computing, all that basic information also makes sense. And then shell scripting is the one that I think yesterday we practiced something like this, moving, removing, and all that. But that also is very much required, because whenever we work on systems, the shell command actually help us to make the work if required. So we cannot at that moment lack this knowledge, because whenever we work on something, this shell knowledge actually comes, I mean, just in part. It's not a dedicated kind of thing that we need to write the shell scripts, but this knowledge help us to navigate in the work when we do something. For example, if you need to connect to database and run the copy commands to copy the data into databases, so that will be a shell command, and that knowledge will help us to like moving to different folders, copying it from here and there, all that thing. And GitHub is, I would say, in general, if we have some knowledge about the version control system, any of that, there are other also, like GitLab is there, but Git is the like the most famous. So even organizations, they use the Git enterprise version, so there also like Git is there. So I think knowledge of Git is also comes very handy. And then knowledge of an IDE, where VS Code is one, then PyCharm is also another IDE. So VS Code is a popular one in data engineering. PyCharm, sometimes data science teams, those guys use PyCharm also, but especially for data engineers, because not only the Python, but we also deal with SQL and extensions. So basically, VS Code comes out a bit as a better tool compared to other tools. And then Jupyter notebooks are also very like much required in today's world. So because Databricks, for example, that is the one of the popular service that is available, and they are on using Jupyter notebooks kind of environment to work on in Spark, PySpark. So therefore, like Jupyter notebooks also comes very handy when we work in data engineering. So that also is like a VS Code plus Jupyter notebook. Then knowledge of databases are also we are supposed to know. So there are like two kind of databases we can divide. So one is relational, where we store the data in tabular format, tables and collection of tables called schemas or databases. And then another one is NoSQL. In NoSQL, there are some categories, for example, key value pair, documents, columnar, graph, and more. So whatever we cannot store in tabular format, we call them NoSQL database. And then knowledge of that also comes handy. And sometimes we have some use cases also. I will be showing that in which cases we can use like handling the data via NoSQL, and we will also see some advantages there. So examples of relational databases are MySQL, Postgres, and MS SQL, Microsoft SQL Server, then Oracle SQL, and then on cloud we have uh, cloud services available specific to different for example RDS in AWS, and the SQL service in GCP. So those are like cloud-based services. And then those are our relational databases. Then we have NoSQL also. A NoSQL example is Cassandra, and then MongoDB, Neo4j. So all those are like NoSQL. We are DynamoDB, that is on kind of a managed service on AWS. So those are like NoSQL, where we store the data in kind of a NoSQL format. It could be key value pair, it could be documents, or it could be like a column-based format where still it's a table, but the structure, the way to store the table is different, where we use it in Cassandra. So those are like NoSQL database, which also comes helpful. Then this columnar is type of a NoSQL, but especially we focus more on columnar databases because we deal with typically tables, and therefore columnar actually help us to make our tables very scalable. So we will also see Cassandra here in columnar. Cassandra is the columnar database for NoSQL. We learn about that, and we have, I think, couple of labs also planned for that. So this one is something we especially focus on compared to graph. For example, graph is something which generally is used in kind of a machine learning models at the moment, but in data engineering the applications are not that huge. There are only few of them, and even those are something which data science team directly handle in raw data format. So for us, our main target would be Cassandra in NoSQL. Then we can also extend it to other databases. For example, Cassandra on cloud, which is called key spaces service, or MongoDB. And then on cloud, it is like from Atlas, we can use MongoDB clusters. So, and then I think CouchDB is also, which we can install locally. So, and then data warehouse knowledge. So data warehouse is also one essential tool, which again is kind of a tabular data format, but it's a total different stream, like databases versus warehouses. We should know the difference. And one major difference is how we store the data. So in databases, those are called OLTP, and warehouses are OLAP. And OLAP means the storage is in the columnar format. So columnar means like for example, the Parquet file is the example of columnar, where if you want to access one particular row, you don't need to read all the rows. Only, sorry, if you want to access one particular column, only that column we can read, because we show that in column manner. So that one column, then another column. So that way we don't need to read all the file. So that way is like how warehouses store the data, and databases is like row, which is the CSV's example of row storage, where you cannot directly access one column without reading the whole table. So that is like we will do it, like we'll focus more on. I will put some theory also in GitHub so that you can read it in a detail also. And then OLAP, OLAP data modeling. Data modeling is important. So data modeling is also one of the core topic that data engineers do, and we often asked us like to build data models for different work setups environments. So data modeling is essential, and we have labs also where we learn how to do data modeling in SQL and in NoSQL environment. So the approach is different to build the data models, and we'll also there learn some basics what data modeling is, and I mean how to build the data model especially. Then this like two kind of processing we do, because processing also something we do, and we need to write code for that. So code could be SQL code, it could be Python code, or you can pick any language of your choice. But processing is something which transform one form of data to another, and we generally divide into two kind of processing. One is called batch, another is called stream. So batch processing means we are getting data at a regular interval, maybe per hour, per day, and it could be irregular also. It's not required on the regular, but in a batch. So that means that batch we process, and then we store it in some storage layer. And then stream means data is continuously coming. It's like kind of a water stream, where batch means, let's imagine batch is like a bucket. You are filling the bucket with water, and then moving it in some vehicle to processing area where you're processing that bucket of water. And then stream means is a pipeline. It's a pipeline. So that pipeline is something which continuously sending you data, and you have to process the data in real time. So, and so you need to connect directly your processing engine to this stream pipeline so that you can process the data. So that is the difference. And this stream is tougher. So these are for advanced level studies only. For beginners, batch is the best one, and we should definitely focus on that. And this covers most of the cases in stream. This covers the advanced cases, and the tools are like in batch mode, we can use Python, SQL, Spark. In stream mode, the tools are Kafka, Spark, streaming, filling. So those are the different tools we handle batch and stream. And then we also need the knowledge of pipelining. So we data engineers build pipelines, and pipeline building means that we call it data pipelines, somebody call it ETL pipelines or ELT pipelines or EL pipelines also sometimes we build. So the purpose is that once you build the system from the raw sources to the final tables, then next time it can run automatically on a scheduled manner. So it's like you are not running it manually or checking it, or I mean doing any kind of things. But once we create the process, it's a one-time activity, and next time we can schedule it. So that, let's say we want to run our process every 1 hour. So we have to build a pipeline that will process all this step by step manner, whatever complexity we have there. And in any way, I mean, we have one more than two tasks on top of that which are dependent on that, and then four tasks which are dependent on those two tasks. So that kind of pipeline flow we have to build. And also we should be able to automate it so that we can say every hour run this pipe again and again on the new data, pull this and all that. So that kind of thing we have to know. And there is a common term there called DAG, directed cyclic graph. So that is something which is kind of a mathematical term also, where it tells us that there should be no loop, because that is not allowed in pipeline. So it is like whenever you move to another node, there is no loop there. So if you want to go back to the previous node, that is not allowed. Like you cannot go back to previous node in any case. It's like only moving forward. So that is called DAG, and that is also comes under this pipeline concept, and data engineers are supposed to know. So these are the core skills that we target. And then some other services which also make uh, us the advanced level of data engineers are knowledge of data lakes and lake houses in detail, infra as a code knowledge, container orchestration knowledge, API, all these points. We have, for example, MLOps knowledge will also come handy, CI/CD pipelines, and then if you know ML basics, that will also be good. That is, I think one more chart which is not showing here is, let me check the definition and then life cycle. And okay, just a moment, let me check which one is that, because that will actually like a different type of pipeline. So therefore, I'm pulling that chart also so that we can again revise the different pipeline concept. Data engineering. Okay. Okay, I think now it should come. Okay, data flow is supposed to be here. Just this one. Open it again. Anyway, like this is the flow that we want. And here it's like we are showing that different kind of pipelines that are available. So for example, if you see here, we have source and we have our data lake, and then finally once we process all this using compute, we can store in warehouse. Now in warehouse also you can see some compute available, because warehouses are have their own compute engines available to them. And so what we are showing here is three type of pipelines. One is called extract and load, in short we call that EL. And in that pipeline, if I ask you like what could be the flow of that, so the flow is that this is the source and this is the warehouse. So the extract and load pipeline means there is no transformation step there. Our goal is to directly extract the data from the source and load into some final destination, because we don't need the transformation step, because the data is already in the consumption format that we need. For example, let's say in the source you have a table, and your analyst team directly want to consume that table. There is no need for any kind of transformation. So that is also one of the case that is usual. So in that case, we build EL pipeline, and that pipeline is like this. This is a flow. So you will, from the source to the warehouse, you will simply load it like this. Now another flow is called ETL, extract, transform, and then load. So that is we extract the data, which we saw earlier also, and then store here, use the compute, this kind of compute, and then load into warehouse. Then it doesn't require this compute. The compute where, I mean, whatever analyst team or data science team run the queries on, that is their compute side. But from our side, for transformation, we are not using this one. Our flow is from here to here, and then using the compute for transformation and then load, ETL. And then another is ELT, extract, load, and transform. This is also one common form of pipeline which we build, and that is we extract the data and store into warehouse. That is the same as this, but this time that data that we loaded is not in the consumption ready format, so we need to also transform it. But this time what we are doing, we are not using this compute, we are using this compute, the warehouse compute. So that is also couple of use cases emerge, like if you do not need to move the data, you are simply storing the data into the table and then using the compute there, the warehouse compute, to transform the data. So that is a easier way to compute or transform the data, and it's actually becoming popular also. But it all depends on if that is possible. So our priority is like it depends on the company, the decisions also, but all that thing is finally what we do, we get the requirements. Like either we need to build ELT pipeline, ETL pipeline. So we should be capable of building all that. And then you will see also combination of all this. Like sometimes you need to build extract, load, and then again that extract load is not like only of this kind, like you will extract here and then load here. No, sometimes you will requirement will be extract from the source and load into some data lake, and then finally after that also you need to build some ETL pipeline. It's like EL ETL or EL ELT. That all combination could emerge also based on the requirement, but these will be the typically you will see the flow patterns. And with that, I think our foundation is now ready. We covered the 4 or 5 concept, which is we should know as data engineers. And in interview also, they will ask you questions around these only, like what do you think data engineers skills are, or what do you think data engineers do in the company, and how you communicate with data science and analyst team, all those basic questions. And also, what do you think data engineering is? And I mean, whatever you saw here in this basic, this is especially designed from those questions in mind, so that after going through this, whatever we just did, you will be able to answer those questions which actually comes during the telephonic rounds mainly, when they give you basic question. And even in on-site also, they might ask you these kind of basic questions during the face-to-face interview. Any questions in this one that we covered from the concept perspective?
No.
No, Sparsh, it was good.
Okay. So let's see what else we have in our plan. We have okay, tools. So now we'll start the tools also. And then in tools, so we have couple of them. We have S3 bucket, we have RDS, Redshift, Glue, and some more. So, but I mean, labs perspective, these will also come here. But here, what we will do, first we will become familiar with the tools. So let's start with the first one, S3. And so if I like explain about what is S3. So S3 is a storage bucket. We call it simple storage service. Therefore, it's like triple S there. Therefore, they named it S3. But it's a AWS service. So, and that service is just do one thing. It store the data, and that data is a data lake kind of format. Like you can store any kind of data there. You can store, because their definition of data is object, and object could be anything which is taking a byte, or you can say like a space in memory or hard disk. So that is something which they consider an object, and therefore we can store any kind of object there. So that is the like one of the popular service in the world, to store all kind of data without worrying about like what, how, I mean the format of the data and all that stuff. So you can store CSV, TXT, JSON, XML, image, video, audio, anything. So that is something we should be aware of. And what we do typically, we first set up the CLI, AWS CLI. So in my system, for example, I have AWS CLI setup, and to set up it, I mean, it's pretty straightforward. It's like we need to create one AWS account, and then on that account we need to create. I mean, we get the credentials to connect to AWS, and then we register the credentials using AWS configure. So when we run this command, they keep asking us like what is the access key ID and secret key ID. So we provide those IDs, and once we do that, our system is configured to connect to AWS. And this is the first step that we do. We configure, yeah, we configure our AWS, and then the second step is we install the AWS CLI. So to install the AWS CLI, there is a pip command. AWS CLI actually available in pip. So if I, the pip command will be pip install AWS CLI. So this command will install the CLI. And what is CLI? So basically, whenever we need to communicate with AWS, one option is to communicate via GUI or via browser. So they have an interface which we can explore. I will also show you that interface in a moment. So that interface is one way, and that they call console. So generally earlier, I mean, console looks like a kind of a terminal, but here in AWS terminology, console is a GUI or the browser that we are using for their, I mean, their service. So that is the console part. That is one way. Another way is via command line. And command line not only like I would say bash and all, but the Python API, for example, if you are communicating via that, so that also come under, they have a term called programmatic access. So that is where these are the two ways to communicate. One is via directly console, and another way is programmatic. Programmatic, again, you can see that we can either use AWS CLI, command line interface CLI, or we can use some other program language, for example, Python. So we can use those also to communicate with the AWS services. So this time, what we are doing, we are communicating with the CLI. So once we configure, install the CLI library, then we are ready. So now if I say, so there are like couple of specific command for S3. So there are operations also that we do. We can create the bucket, we can delete the bucket, we can upload the files and folders inside the bucket, we can download the folders and files. So remember in one of our cases earlier, I showed you one data where we were storing the data into S3. So I told you that this is a place where I am storing my data, right? So let's explore that first, and that is a S3 part also. So what I'm doing here is in this one, I am saying this is a format like what we do in a format perspective. If I open a note, S3, yeah. So there is like AWS we mentioned because it's like it will tell our terminal to use AWS CLI. Then we say S3, and after that, if you want to copy something, we say CP, and after CP, we say source, and we say target, right? So now there is another command called just like this, but the keyword is sync. So what we do, let's say you want to copy one file from your local system to S3 bucket. In that case, we will use CP command. And let's say you want to copy in another case the whole folder, whatever is inside that folder, you want to copy that complete folder into your S3 bucket. In that case, we can again use CP command with recursive like this, right? This is also possible, but recursive indicate what it generally indicate in our bash also, because you might have noticed that when we were deleting the folder, we need to say rm, but also -r, so that -r and minus recursive are same, so that we indicate it's a recursive operation, and that generally applies for folder. We can also do this for folders, but there is another keyword called sync. Sync is generally used for folders only. So whenever you need to copy the folder, you can also use this command, your source folder and the destination, target destination in S3. Now the difference between these two, like these two are doing again the folder copying, but the difference is that if you have 10 files in your source folder and you are copying the 10 files again, I mean that into the target S3 bucket, it will copy and it will also copy. But next time, if you copy again, if you run this command again, it will again copy those 10 files. But in sync, it will not copy. It will say, we are skipping those files because it already exists and there is no change. So it has some special power. It will first check if whatever you are trying to copy, if there is already a file there, and not only name, it actually has internally a hash which it stores, and you don't have to worry about the internal operation of that. But what happens, it automatically check the state also of the file, if state is changed or not. So if the file is same, there is no change, it will not copy. So let's say if you want to move 10 GB of data, then you should use this one. If you like trying to overwrite, then generally we can use this also for folder, but in some cases only we need to use the override set. Otherwise, if you want to only sync, like if you want to update the target folder with the new changes only, in that case you should definitely use sync, because you are saving a lot of data transfer cost and time you are saving. because you are just copying the changed file only. So this is the set of command, and then let's say you want to do the reverse. From the S3 bucket, you want to copy something to your local. Then command will be same. Everything will be same. Only these two places will be switched. Instead of now the source will be your S3 bucket and target will be your local system. So that will be the only change. And these are the only, I think, three commands that we generally use for copy and sync and all that thing. So let's do some activity now. Let's say in this, I think, yeah, here also I can show you that operation, that in SQL, let's say I want to, yeah, ls also we can include here. This also we typically use S3 ls. Ls is for listing. You can see the comparison now. If you know bash, then you can easily relate all these like cp ls. In even in sync also there is a sync command in bash, but because we generally don't use that, therefore we do not cover that. Otherwise there are like huge number of commands in bash, but sync is also there, which actually do something like that also, but we use it for S3 specifically in a data engineering cases. So ls is actually listing. So it's like if you want to say what is your source. Source means, I mean, your path. I would is this time it's not source target, but I would say S3 path. If you want to list out the files in your S3 path, you need to say like this. We need to put the forward slash also, because in S3 there is a concept of folders and file. So S3 indicate the folders with the forward slash sign. So in this also, it I would say it could be a bug also, but internally they might have something which require this for them. But I would say in GCP, this is not required. You can simply list out like this and it works for folders also. But in AWS especially, we need to also use the forward slash for listing the files inside the folder. So this is your S3 path, and this command list out all the files which are available inside the folder. So now let's say I want to list out what is inside this. In the format also, let me cover that because that also creates some confusion. So the format in which we mention the S3 path is like this: S3 colon forward like this, and then bucket name, and then your path one, then path two, something like that. It could go to a number of times. And then here bucket name, again there is a logic in bucket name that it should be unique globally. Bucket name should be unique globally. That means if I create a bucket, nobody else in the world can create that bucket again with that name. And similarly, the vice versa. If somebody else creates some bucket, I also cannot do that. Like it is a unique name globally. It's not only account specific, but in S3, it is a global naming convention that once we have a bucket name, nobody else can do that. So in my case, you can see that if I simply copy this command also here. So here you can see that what I'm doing, I am mentioning that I want to use AWS CLI and then S3 service and then sync. So that means I'm trying to do some operations on folder level. Here I am saying my source and my target. So let's understand the source. In source, I can see that I am mentioning S3 colon 2 times forward slash. And then it's the same format that we also use for website like HTTP, HTTPS, something like that. Then this is my bucket. And then this is the path where my actual data is there. And this is a source. And what I'm doing, I am syncing that particular folder to the current folder wherever I am, and I'm running this command. That folder and this folder will be in sync. That means all the files which are there will be copied to the current folder. That is what I'm doing. And another way to understand sync is that what we generally do, we are saying this folder and my current folder should look same. It's like that folder is like my this current folder, or you can say data also. So that means from my current location, this folder and the cloud folder will be same. Whatever inside there will be inside there. That is also easy way to understand sync. So this is the command I'm using. Let's say I want to list out the path. So you know that I need to put the forward slash also. So let's try without forward slash first. I would say AWS S3 sync. Oh, sorry, LS. I'm listing out, and I would say this command. This is a path. Here, if I simply write this, you can see one output is there, which is like data forward. Whenever you miss the forward slash, you will simply like this. So they are saying it's a kind of a folder, and therefore whenever you get something like this, that means it's not a file but a folder. So what you will do, you will say like this. Now you can see that these are the different file listings that we have. So we have a couple of CSV files available, and we can also see name and the sizes, and also the last change date or upload date. And then we have all the listings available here. So this is what we are using the listing part or the listing command to list out the files. Now let's say I think yeah, we can also create the bucket actually directly from here, but I want to show you from the GUI because we are just starting. So what I will do, we will create a new bucket, and in that bucket we will put some file, and then we download it also, some kind of that activity. So if I share my screen, yeah, I would say S3. Let me sign in. So this is the GUI part, like this is a console, how it looks. So whenever you go to the AWS console, like this address console.aws.amazon.com, you will see some kind of GUI which we can access from browser. So this is like how it looks, and inside this your different services. So to go to S3, we say S3. We search for S3, and you can see that we have S3, and we click on it, and it will bring to the home page of S3. Here we click on to create a new bucket. We click on create bucket like this, and from here we name our bucket. So let's try to name it something. So generally what I do, I would say Jan 6 20, no, training, and let's say date. So let's say today's date. So we will say year, month, and date, something like this. It generally works actually, like to pick a unique name. but it could be any name. Once you have that, all these are default, and we say create bucket. It generally like take very less time, only few seconds, but my network is a bit slow maybe. Therefore, it is also taking some time to get the command back. So all we need to do, like you can select default. If you want to change the region, you can change the region also. And then if you want to make it public, we can also do that. But all these are like they make it default, and that is something we need. And only thing is like we have to select a unique name. Okay, they are saying they created the bucket, and now we are ready to use that bucket. So if we move to that bucket, this one that we created, it's like a folder now. It's like hard disk on cloud. So, and advantage of this is it is scalable. That means there is no size limit of this bucket. You can put any number of amount of data here. It could be terabyte, petabyte in a single bucket. That is possible. So what we are going to do now, let's upload something here, and let's copy the name of the bucket also. And here we'll say, okay, here we keep building our command. So let's say, okay, I'm in this root folder. So let's say I want to copy. What is this xorc? Let me chat the data engineering basics data. Okay, let's say I want to download something from here first. Let's say, or this file name also we can upload. So our goal is to upload this particular file. Let's say that, and 01 data ingest. So what the command will be? We will say AWS S3 CP and my source. My source is from the current folder because I am in the folder which is like this folder, root folder of this workspace. Now, if I minimize all this, I can see that I need to go to SQL, and then this is my file. So I will say SQL and 01 data ingest dot ipynb. So this is my file, which is the source. Now I need to pick the target because of this AWS S3 CP, my source, and my target. So target is S3 bucket, and the format is like this. So I need to first mention S3, then my bucket name, this one, and then inside that we can decide where we want to put our file. So let's say I want to put our file inside notebooks folder, and it will automatically create the folders. Whatever folder we create here, it will automatically create during upload. So notebooks folder we are creating, and inside this we are saying data ingest. So you can see also that not only the notebook the folder creation, but also renaming. From the source we are also renaming our file, so that is also possible. We can rename our file. So let's run this command, and once we run it, it will give us some acknowledgement that file is uploaded. That acknowledgement tells us that uploading is done. Now we have to check, or I mean check is optional because we anyway got the acknowledgement. So here it's like upload, and upload from the source, this folder, to destination like this. So you can see that notebooks, whatever destination we give, it's that one. So let's check it now. If I refresh, so there is a refresh button here. So we don't need to refresh the complete page. We can simply refresh our only the objects from this button. And generally in AWS, you will see that most of the services support this kind of button for one section. So that is a better way to refresh. You can see that the folder is coming and forward slash also there. Forward slash also indicate it's a folder. Click on it. Then we are expecting one node called data ingest here. You can see that the data uploaded successfully. So this is how we upload the data. And same way we can download the data. So let's say I want to download it. So now you can imagine the command also, right? So let's say create a new folder called temp. Folder is here, blank. Our goal is to download this particular file inside this temp. So let's do that. AWS S3CP and our source path and the target path, which is temp. Now, if you do not want to like rename your file, you can simply say like this. That will actually uh, like copy the same file into this folder and with the same name. But if you also want to rename, or you can also say like this is also fine. Without rename also, you can simply mention the complete file name, but you can leave it up to here. This will automatically place your files inside this folder. That is also we can use. So let's do that. So it's a download process. So we will get some acknowledgement about download. You can see download, and they are mentioning the source and target also. So we can see our file here. Similar way, we can download, upload any kind of file from any bucket to local system or to any other S3 bucket also. That is also possible. Like copying directly from one S3 part to another S3 part. That is also possible. And let's now work with folders. So for folders, we know that there is a sync command. So what our goal is now to in this temp directory to directly copy the whole notebook folder. So what we will do, AWS S3 sync, and our source target is, our source is this one, and our target is temp. Again, you can leave it like this, or you can again mention the folder name, or you can also rename it. That is also possible. So you can say temp NBS like this. So that way your folder will be like this. Now this one and this one it will be in sync. So our NBS will contain what? It will contain the same file which are in this bucket, in this folder in cloud, which is like this one. In our NBS also the same file will occur. Yeah, we can see that source and target. Now temp NBS and our file is there like this. So now this one NBS is same as we synced it from the source, which is like this folder. That way like sync works. I think this covers all the required elements that we need from S3. Now, what I would recommend you, I would recommend you to read more about it and practice some more commands which we not covered, which are like go to AWS CLI and you will see one documentation, official documentation of this and specific to S3. Yeah, so go to this one and you will see all set of command which we can use. So there are like a lot of commands you can practice on. So the more you practice on commands, the more it will become familiar. But I covered 2, 3 essential ones that we typically use a lot. And if some other commands will come, you will be familiar with that because you know the format now, like what we need to do, source, target, and all that. So go to this particular path and you can easily Google it and search all that, like S3 one especially for AWS CLI. And here you can read all the description, knowledge of this, and you can see that what we use in local Linux or Unix machines also works here. So you can also read like advanced concept, like if you are interested, you can read about like this. Like if you are uploading, downloading something, You can also include the formats like only upload the JPG files, something like that we can do. Then these are like typically categories we use. So MB is something to create the bucket. So I would recommend also that just like we use the console to create the bucket, use MB to create the bucket. This also is like from the command line, we can create the bucket. Then CPLS and move, just like copy, move is also possible. So try this, like moving the files from one place to another. Try this also. And then yeah, RM and RB are like opposite. MB opposite RB, remove, and RM is like remove, and then sync covered. So I think try MB, try move, and RM and all is fine. No need to do that. But yeah, you can also try RM, RB also if you want. But generally we do not use those much because sync I think yeah we use a lot. Then LS and CP also, but move, MB and all that, whatever is your interest, based on that you can even explore it further. But now you know the trick, like what we need to do and all that thing. This is S3 bucket. Now let's go to another one. Any question in S3? Okay,
Yeah, again I have to watch the video. Like everything is little bit confusing.
everything is confusing.
Yeah, means this is my first time listening, so I have to watch the video again. Not everything, a little bit confusing.
Okay, okay. Yeah, I mean that makes sense. Yeah. I mean,
Yeah,
commands are like confusing. You can understand, and yeah, I mean, you can watch the video and then, I mean, we even keep practicing it in some tutorials. So there also it will be revision, but yeah, I mean, make sure that AWS S3 is like root. So S3 command are good, and we should know. So practice again if you need. And then I think next what we will do after S3, we will also go with other services. Like one service which we have in mind is some database service. So what we are going to do, we are going to create a database, Postgres database actually is already there. I will show you the process steps that you can follow to create database there, and we will actually explore, just like we explored S3, we'll also explore the RDS service next. So there we will learn about databases. So how we will see how to work with Postgres and MySQL databases there. So RDS is a service which is like relational data service. So relational database service. So that means it's kind of a database but on cloud. But if you want to use some database, then you can use this service. So for data engineers, this is like also one of the essential service we use. And next we learn about that. And then warehouse. So there is a warehouse service called Redshift, and it's Amazon specific warehouse, and we also learn about that. And then again we work on that with like how to work basics or Redshift also, that we have knowledge on that. And then another tool, Glue, and then Athena also. A couple of them are like, only few of them are essential, which we are supposed to know. So we will know and learn some basics of that. Yeah, I think yeah, we'll tomorrow are we connecting? Saturday.
yeah,
Okay. Yeah, we will connect tomorrow then. Thanks, Pawan,
yeah.
Tahir. Thank you.
Thank you,
Bye.
thanks.
Okay, Pawan.
Bye.
So tomorrow we will connect at same time. Okay.
Yeah, it's fine.
Okay. Tomorrow and on weekends maybe Sunday we will also connect.
Yeah, every day is fine for me.
Okay.
Okay. Yeah, sounds good.
Thank you.
Thank you. Bye.